What is DNS, or domain name system? In this video, I'm going to explain it in a lot of detail, but before we get there, Alexa, nslookup amazon.com.
The DNS lookup for Amazon.com is 176.32.103.205.
That is an example of what DNS does. It's essentially resolving a name, typically a domain name, to an IP address. Now, before we get started with the technical content, I'm trying something new in this video. This is a sponsored video. It's sponsored by fasthosts.co.uk. But not only are they sponsoring this video, they are also sponsoring an amazing giveaway. Someone is going to win free flights, free accommodation, and free entrance to South by Southwest. What a fantastic prize to win. Now, to win this prize, you need to know the answer to this techie question. Which protocol is used to resolve domain names such as fasthosts.co.uk to IP addresses? If you know the answer to that technical question, you can enter using the link below, but please, before you do that, be aware that this competition is only open to UK residents. Now, if you're not based in the UK, don't worry. I've also hidden some extra giveaways in this video. So use the hidden links in this video if you want to win some additional prizes. But the main prize is this fantastic giveaway. Someone is going to win free flights, free accommodation, and free entrance to South by Southwest 2020. Fantastic giveaway. Now, let me know what you think. Would you like more of these sponsored videos and more of these sponsored giveaways? If I get companies to sponsor videos and sponsor prizes, that means that more of you have the opportunity to win something really cool. So what do you think? Should we continue with these sponsored videos and sponsored giveaways? nslookup.google.com.
The DNS lookup for Google.com is 172.217.164.142.
We as humans don't communicate easily using IP addresses. We use domain names. So if I told you to go to Google's IP address, you probably don't even remember what the IP address was, but you'll remember what google.com is. So DNS essentially resolves a human readable name such as google.com or amazon.com to a machine readable IP address. Machines don't use names, they use IP addresses. In IP version 4, we use dotted decimal notation IP addresses such as 192.168.1.1. IPv6 uses IP addresses such as 2001::123. There are many IP addresses out there and many websites. It's much easier to remember a domain name, once again, like facebook.com or amazon.com, rather than the IP address of a server. And to further complicate it, like in my example, depending where you are in the world, a domain name may resolve to a different IP address for load balancing. So if I'm in the UK and I ping google.com, I may get a different result to you if you're in the US or in Singapore or somewhere else in the world. It's much easier to remember the domain name than it is to remember an IP address. But machines use IP addresses and traffic is routed across the internet using IP addresses, not names. DNS is a fundamental building block in networks today. Without DNS, internet wouldn't really work very well because very few of us are going to remember IP addresses. Now, as an analogy, DNS is like a telephone book, taking a name, converting it to a telephone number, but in this case, taking a domain name and converting it to an IP address. In the bad old days, I'd have to look up someone's number in a book, and then I'd have to manually dial their telephone number, but I don't think any of us do that these days. On a phone like an iPhone today, we're not going to manually type a number like this and then dial it. We're going to go to our contacts and search for a contact and then just press on the contact to call the person. I mean, a lot of us probably don't even know our own telephone numbers these days. We don't know the telephone numbers of other people because we simply look them up in a directory on our phone. Now, this is a local directory. We can do something very similar on a PC by using what's called a hosts file. That is the most basic version of so-called DNS. Now, it's not DNS, but it's a local lookup. So you could create your own version of DNS locally on your PC by editing the hosts file. Taking that a step further, companies may have a local DNS server that resolves names within the organization. But on the public internet, we have distributed DNS systems that allow us to resolve names such as Google, Facebook, etc.
Welcome to the future. Come, explore and experience the world of tomorrow, today.
Now, if you know me, you know I like to give things away. However, it wouldn't be possible to give away the amount of stuff that I give away without the sponsorship of companies such as fasthosts.co.uk. So I really want to thank them for sponsoring this video, really want to thank them for sponsoring this amazing prize where someone is going to win free flights, free accommodation, and free entrance to South by Southwest. Now, to win this prize, you need to know the answer to this techie question. Which protocol is used to resolve domain names such as fasthosts.co.uk to IP addresses? If you know the answer to that technical question, you can enter using the link below, but please, before you do that, be aware that this competition is only open to UK residents. If you're in the market for domain names, or dedicated servers, or web hosting, or email services such as standard email or Exchange, or WordPress hosting, then FastHosts can help you with that requirement. They've been providing services since 1999. They have over 1.2 million domains hosted, over 650,000 customer mailboxes, over 320,000 websites are hosted by fasthosts.co.uk. You can also partner with them if you want to resell hosting. So have a look at their website if you're interested in registering a domain or you want to host a website. You need a quick and easy way to build a website, or you need to host your email, or if you need a dedicated server or virtual private server, or if you want to simply resell their hosting and start your own web business. Okay, so once again, I really want to thank FastHosts for their sponsorship of this video and the sponsorship of this fantastic prize. Have a look at their website if you're interested, once again, in registering a domain or if you want web hosting. Okay, so let's continue with the technical video. Now, it's all very good and well talking about DNS, but I want to show you practically how it works. I'm going to show you Wireshark captures. I'm going to show you how to set up a DNS server on a Cisco router, how to set it up on an Ubuntu server. I'll show you basically how you can manipulate DNS to do anything that you want. You need to be careful that you use trusted DNS servers. Don't just trust any DNS server out there. DNS can be intercepted, and you can manipulate the DNS servers used by PCs to get them to go to the incorrect domain. Fortunately, today, a lot of browsers like Chrome have a whole list of certificates preloaded on them, so you'll get a warning if you end up going to an incorrect domain such as Microsoft.com or Cisco.com. Okay, so in this topology, I've got a Windows 10 computer. It's connected to a Cisco switch, which in turn is connected to a Cisco router, which connects us to the internet. This topology is running in GNS3. I'm hosting this entire topology on my computer. So forgive me if the fan goes a bit crazy. It's all running locally on my Mac. I also have an Ubuntu PC, which we'll configure as a DNS server. Okay, firstly, let's have a look at the Windows computer. Here's my Windows PC. I'll open up a CMD prompt, make this a bit bigger. ipconfig shows me that this is the IP address of the PC, IP version 4. Default gateway is 10.1.1.254, and I should at this point be able to ping my default gateway, which I can. Default gateway is this Cisco router with IP address, once again, 10.1.1.254. The switch is a layer 2 switch. It's not really doing anything except giving connectivity in the network. So back on the PC, ipconfig/all shows us that this PC has two DNS servers configured, 8.8.8.8 and 1.1.1.1. In other words, Google and Cloudflare are the two DNS servers configured on the PC. So I'll start a Wireshark capture between the PC and the switch so that we can see what's actually going on. Windows sends a lot of traffic into the network. So as you can see here, a bunch of traffic is being sent by that Windows computer out into the network. But I'm going to filter for DNS. And then back on the PC, what I'll do is ping a domain such as davidbomble.com. And notice we get a reply from this IP address, 217.160.069. Now the CPU is spiking on my PC here. The throughput through a Cisco switch and a Cisco router running in GNS3 may be a bit slow, but the point is that I am getting replies back to that domain. And if we have a look at the Wireshark capture, what you'll notice is we can see that this IP address, 10.1.1.1, sent a DNS request to 8.8.8.8 for domain davidbomble.com. So just to confirm, on the PC once again, ipconfig shows us that this is the IP address of the PC. The PC sent a request to the DNS server. Notice the query is for davidbomble.com. It's a record. A record is a domain name in IP version 4. Quadruple A is a domain name in IP version 6. So the PC is asking the DNS server what the IP address is of this domain name. Now going back a step, at a layer 2 in the OSI model, or TCP IP model if you prefer, we have Ethernet 2. That's because this network is using Ethernet. So it's an Ethernet connection from the Windows PC to the Ethernet switch. The source MAC address is the PC, destination MAC address is the router. Basically, the traffic is being switched from the PC to the router because that's how it gets onto the internet. So at layer 2, source MAC address will be the PC, destination MAC address will be the router. But at layer 3, IP version 4, source IP address is the PC, destination IP address is Google. Now, you may notice that this is a RFC 1918 address. In other words, it's a private IP address. It's non-routable on the internet. But the router is implementing network address translation, or NAT. This is very typical of what your router at home will be doing. So notice it's natting this IP address. Now it is natting it to another RFC 1918 address, but that's because this router is connected to a cloud, which is actually bridging my PC physically. So this PC here onto my physical home network, and I have an internet router that routes this onto the internet. So it's actually being natted multiple times. But what's important to point out here is notice the protocol at layer 4 is UDP, or User Datagram Protocol. Source port number used is 52749. That is what's called an ephemeral or random port number. Destination port number is 53, which is the well-known port number for DNS. When a server is configured to host multiple services, it's got to serve a purpose. So it's a server that's acting as, let's say, a file server. When you connect to that server, it's going to give you a file. But when you connect to it using DNS, it's listening on port 53 if it's been configured as a DNS server. So you send traffic to port 53, the server is listening on port 53, it's running an application like, which I'll show you in a moment, Dnsmasq, which is a DNS server application, and then it responds back to that request on the port number that you chose. So if you connect to a DNS server like this PC is doing, you will use a random port number or ephemeral port number going to a well-known port number, and then it'll reply back from that well-known port number. And we can see that here, Google is replying from a source port number 53 going to the port number that the PC chose. The Windows 10 PC chose this port number. The Google DNS server replies back to that port number. So again, it's UDP. Destination port number is this. Source port number is this. Digging deeper into the DNS information, we can see domain name system. It's a query. It's a standard query for a name. We're trying to resolve a name. The name that we're resolving is davidbomble.com. And the DNS server replies back saying, this is the answer. This domain name has this IP address, 217.160.069. So back on our Windows PC, that is the IP address that we see. So I could copy that IP address, go to a web browser. If I type the domain name, it's going to browse to that server. So I'm able to connect to the domain using the domain name. And this depends on the server. I should be able to connect to the IP address of the server. In this example, I'm getting a 404 error. Now, some servers will not allow you to connect directly on the IP address. That's typically because multiple domains are hosted on a single IP address. Okay, I'll stop the Wireshark capture. And what I want to show you once again is that DNS is essentially just a resolution of name to IP address. And you can do that directly on your Windows computer. So in Windows, I'll open up Notepad. I'll run this as an administrator. Before I open a file, if I ping router 1, notice we told that that domain name is not found. The same with router 1 home.com. The ping request times out. I can't ping that domain name. But what I could do is open a file, and what I'm going to do is go to C Windows, System32, drivers, etc., and I'm going to open the hosts file. This is a file on the local Windows computer. Just zoom in there to make it easier to read. And I can edit this. So I could say 10.1.1.254 is router 1 and 10.1.1.1.254 is router 1 home.com and save that file. So I'm editing a local file that maps host names to IP addresses. So now when I ping router 1, notice that works. When I ping router1.home.com, that also works. But if I ping router 2, that fails because it's not in the host file. And Google is not replying back with that information. So if I said R2 like this and save that file, now ping R2, that resolves. Name got resolved to an IP address. Now in this example, the network's a bit unstable, so the pings are timing out. There it succeeded, but the important part is the domain name got resolved. That name got resolved to an IP address. If I remove these entries from the hosts file and save it, I'll clear the screen there. When I ping R1 now, that's going to time out because I don't have an entry for that domain name. That's essentially what a DNS server does. It takes a domain name and maps it to an IP address. Now on this Windows computer, I'm going to change the DNS server to the Cisco router. So go to the Ethernet settings. Rather than using Google as the DNS server and Cloudflare, I'm only going to specify my local router as the DNS server. Now in this example, I've configured the router to accept DNS queries and answer them, and if it doesn't know the answer, to forward it to Google. This is once again a Cisco router, but your home router probably does something very, very similar. So if I type show run pipe include, which basically allows me to look for a command and search for DNS, you can see that I've enabled IP DNS server. So the router will act like a DNS server. Show IP route shows us that it has a default route to a router physically in my local network. That's another Cisco router that actually physically connects me out onto the internet. This device can ping google.com. So if I type show run pipe include name, typically I would have IP name server, something like this, but it actually got to that because the outside interface, in other words, the interface connecting this device to the internet, is using DHCP. So through DHCP, it'll learn the default gateway. It also learned the DNS server information. So once again, it could ping davidbumble.com as an example. Now the PC won't be able to ping router1.home.com as an example because the router isn't configured with that information. On the Cisco router, if I try and ping router1.home.com, that's not going to work because it doesn't know about that domain. Notice it's actually trying to get to the internet router to try and find out what that domain is. But if I type IP host and specify a host name like router1home.com and then specify an IP address of, let's say, 10.1.1.254, the local router, this router will be able to ping itself. It's done a name resolution locally, and the PC will also be able to ping that domain. I'm going to flush the DNS cache so it doesn't have any cached entries locally, and then in GNS3 I'll run a Wireshark capture here, and what we'll filter for is DNS. So basically we'll see a DNS request from the PC going to the router and the router replying if it does a DNS request. So ping r1home.com, that works. In Wireshark we can see the DNS request from another random or ephemeral port going to port 53, but the DNS server is 10.1.1.254, which is the local router. It's asking for the IP address of this domain name, and the router is replying back saying the IP address of that domain name is 10.1.1.254. So standard query for an A record because this is IP version 4, but in this case the query went to the router. Now the router is going to forward on DNS queries that it doesn't know the answer to, and we can prove that by running a Wireshark capture between the router and the internet, so on this link. So we're seeing a whole bunch of traffic because that is bridged to my physical network. But once again, what I'll do here is filter for DNS. You can see some other DNS queries already taking place. On the Windows PC, I'll ping davidbumble.com once again. You don't have to use ping, you could use nslookup. So let me show you that as well. But notice it did get resolved, and it looks like it didn't get forwarded. So let's do an nslookup for a different domain, let's say cisco.com. Resolution is this IP address. So notice there we go. We've done an nslookup. Notice in this case, it's a DNS query for both the IP version 4 address. So we've got a query for the A record, cisco.com. And then we've also got a query for the IP version 6 IP address. So in this case, the reply came back saying, this is the IP address of Cisco, IP version 4, and this is the IP version 6 address. And we can see that here, IP version 6 and IP version 4 in our Wireshark capture. Notice that the source IP address is 192.168.167, which is actually the router. Show IP interface brief shows us that that is the IP address of the router. So the router is querying another device for the IP address information because it doesn't know it locally. So that's the whole idea with DNS. If the local DNS server doesn't know the answer, it forwards that query to a more authoritative DNS server. And in this case, we're getting both the IP version 4 IP address as well as the IP version 6 IP address because I used nslookup. Now you need to make sure that the DNS server that you're querying is giving you good information. As an example, on this router, I could create a host name for cisco.com and simply point it to another IP address, let's say the local router. On the PC, I'll flush the DNS cache, so flush DNS, and then I'll ping cisco.com. Notice the IP address resolved is 10.1.1.254. It's not the actual IP address of Cisco. So if your DNS entries are manipulated or you're connecting to a false DNS server, you could end up going to the incorrect server. You may think you're going to cisco.com or another domain, but actually you've been redirected somewhere else. So hackers will often target DNS servers, have rogue DNS servers, which allow them to push your traffic where they want to. Again, fortunately, because the certificate's preloaded on browsers today, you may be warned if you go to the wrong server. Now, typically, you're not going to use your Cisco router as a DNS server. You might use it to forward DNS requests onto a DNS server on the internet, but you wouldn't want to configure your local router as the DNS server. You may in some cases, but typically not. What you typically want to use is a Linux server to be the DNS server. So in this example, I'm going to show you how to set up a DNS server on a Ubuntu computer. Now this is a Ubuntu desktop. Typically you'd run this on a server rather than a desktop, but the same principle applies. So ifconfig shows us the IP address of the server. Can we ping google.com? Yes, we can. So we're getting a resolution of that domain. Now to set up this Ubuntu PC as a DNS server, I need to disable systemd resolved because there's a conflict on port 53. You cannot have two services listening on port 53. I want to set up Dnsmasq, so I want to disable this process so that Dnsmasq can listen on that port number. So I'm going to disable systemd resolved, and then I'm going to stop it. I'll put all these commands below this video if you want to access this yourself and see the commands. Next thing I'm going to do is edit. I'm just going to use nano for that to keep it simple. resolv.conf. Nameserver is set to this at the moment. I'm going to set the name server to Google. And then I'm going to do sudo apt update to update references. It might be a bit slow here because I'm going through the GNS3 network. Going through Cisco devices like this in GNS3 is very slow. So I'll speed the video up if necessary. Okay, so the references have been updated. So what I'm going to do is install Dnsmasq. And that's now been installed. Now my Mac is going crazy. There seems to be an issue with VMware Fusion and a Mac where the CPU starts cycling like mad. So I'm sorry if there's a lot of background noise, but hopefully you can hear what I'm saying. Now to edit Dnsmasq, it's not that difficult. I'm going to edit etc Dnsmasq conf. Now there are quite a few options that you can change here, but I'm just going to change some of the basics. Set the port to 53, that is the default. For housekeeping and to be a better net citizen, I'm going to uncomment domain needed and bogus priv. So we'll never forward plain domain names onto the internet and non-routable address space. And then essentially all I need to do is uncomment this because I don't want to use etc resolv. I'm going to put domain names directly here. So what I could do is simply add domain names like r1.home.com and the IP address and whatever other domain names I want to enter. So let's say my router, home.com, same IP address. And then all I need to do is save that file. and then restart the service. So sudo systemctl restart Dnsmasq. I can look at the status if I want to. You can see that this lightweight DHCP and caching DNS server is running. So now on my Windows PC, to prove the point, let's configure the DNS server to the Ubuntu PC. So I'm going to set the DNS server here to 200, which is my Ubuntu PC. And click OK. So let's flush the DNS. DNS has been flushed. Do that again. So can I ping r1.home.com? Yes, I can, because that's been resolved by the Ubuntu server. Now that was quite a long video, but hopefully you've learned something. I've shown you how to capture DNS queries and responses using Wireshark. I showed you the source and destination port numbers. I showed you how you can configure a Cisco router as a DNS server and how to configure an Ubuntu PC as a DNS server. And then we tested the queries and made sure that it worked properly. I'm David Bombal, and I want to wish you all the very best.